Okay, this is 7th grade lesson 6.3 part 2. Today we're just going to be working with lateral surface area of a cylinder. So it's actually faster than doing the surface area of a cylinder because the lateral surface area is just that middle piece or that middle rectangle. Standards covered are 7G, 4, and 6. And once again, our page numbers are 262 through 267 out of the hardcover book and 145 through 148 out of the practice journal. Today we're going to be working with lateral surface area, and you might be asking yourself, why would we have to ever just know the lateral surface area? Well, for example, in the real world, if I were maybe somebody that worked for maybe Campbell's Soup Company, for example, and it was my responsibility to design the can and then to come up with the label, well, I'm going to have to understand how to find the lateral surface area or how much paper I need to actually cover this middle section of this cylinder. So your lateral surface area is just that very middle section of the cylinder. It does not include the top and the bottom. Okay, so just understanding basically what lateral surface area is. It's that middle piece that connects your two bases. Okay, our bases are our circles. So we really have a figure for our lateral surface area that is a rectangle. Okay, and the height of that cylinder was 6 feet. And the distance around this is our circumference. Well, that's the same as this. Remember that from part 1. Okay, so our circumference of a circle is pi times diameter. Okay, so our diameter on this would actually be 20 across. So 3.14 times 20. Okay, so 3.14 times 20 is going to give me 62.8. And then we're going to take that times 6 feet. And when I do that, it gives me 376.8. It's lateral surface area, so that would be feet squared. Okay, so the key thing, make sure that as you're working through any of these cylinders, pay attention to what they're asking for. Do they want the full surface area or do they just want the lateral? Because lateral surface area is just that middle section. It would be that section of where the label is on a can. Okay. All right, so let's go ahead and try another one. And yes, it's as easy as that. That's all we have to do. You would think we should have maybe learned this as the first part, right? Okay, so the lateral surface area on this one, this time they're giving us the diameter. So make sure you're paying attention to what they give you for your dimensions on that circle. So we've got our rectangle, which is our lateral surface area, and the height is 2 meters. Okay, and we're going to do pi, 3.14, times the diameter, which they told us was 14 this time. 3.14 times 14 gives us 43.96, and we're just going to go ahead and take that times 2. And when I do that, I get 87.92. Units were meters, and it's surface area, so it's squared. Okay, pretty simple, not too terribly hard. So I'm going to go ahead and give you guys one to try. Like I said, it's fewer steps than what you had to do yesterday, but it's just introducing you to that concept of lateral surface area. So here it says how much paper. So this would be like a real world application of understanding why you would ever need to understand just lateral surface area. It says how much paper is used for the label for this can of peas. What is the height of the can of peas? What if the height of the can of peas is doubled? Does the amount of paper used in the label double? So what I want you guys to do is go ahead and pause your video, and I just want you to find the lateral surface area for this sweet pea label to begin with, and then we'll discuss out the doubling part in just a minute. So go ahead and pause your video, work your way through finding that label portion of that can, and then start it back up to check your answer. Okay, so for that label, you should have gotten 25.12 inches. Okay, 3.14 times 2, and then you take that answer times, I don't think I had that right. No, I don't. I accidentally doubled it. This should have been 24.8 3.14 times 2 times 2 gave me, sorry, 12.56. I accidentally was writing out my part of my answer, or I was mixing my two things together. So here it says, what if the height of the can of the peas is doubled? So if we double the height, well, we double this to now 4. So you should have gotten 12.56. So if we doubled the height, well, that's not going to change the radius or anything. It's just going to make this label taller. So this is now 4. We would still have 3.14 times the diameter of 2. So 3.14 times 2, then take that answer times 4, gives me the 25.12 that I had written down earlier. Okay. It says, does the amount of paper used in the label double? So if we want to check if it doubled, well, we can take 25.12 and just divide it by 2 and see if it gives us the 12.56, and yes, it does. So this would be a yes statement. And I apologize for mixing those up. I forgot that I had already done the second problem when I was writing down my answer. Okay, so here, once again, lateral surface area is just working with that very middle section. Places that it might be used in the real world would be for, like in companies where they're working with that middle section and covering it and having to understand how much area needs to be covered there. Okay, so we're gonna go through one real life application using a concept here with full surface area. So it says you earn 1 cent for recycling the pecan. So we get 1 cent if we take in that pecan. How much can you expect to earn for recycling the tomato can? Assume that the recycling value is proportional to the surface area. Okay, so let's go through and find the surface area. So this is the same one that we just did on our previous slide. So if we jump back, if I jump back to my slide, wasn't it like 12.56? That was for the lateral, just the lateral. I need the total surface area. So when I did this middle section, remember that was 3.14 times 2, and then I take that times 2, that gave me the 12.56. Now, but they want the whole can, the whole surface area. So I have to also include my top and my bottom. So that's pi times radius squared, so 3.14 times 1 squared is still going to give me 1, so I get 3.14 for this. So if I add all those together, okay, the surface area of this can is 18.84. Okay, and that's going to give me, I get 1 cent for that. That's how much they're going to pay me for that. So I'm going to set this up as a proportion, and then we're going to go through and see how much we think we should get paid for this bigger can. Okay, so we've got the same thing. We've got the top circle, and that's 3.14 times 2 squared. Okay, radius squared, so times 4. 3.14 times 4 gives me 12.56. Okay, I'm going to have the bottom the same way. And then I've got this middle rectangle, and the height of that rectangle is 5.5. And then this is pi times diameter. My diameter is 4. Okay, so 3.14 times 4 gives me 12.56. Now I have to take that times the height, so times 5.5. So the area of this is 69.08. I'm now going to add all of these together. So plus 12.56 plus 12.56. So my surface area on this tomato can is 94.2. Now, the question is asking, assume that the recycling value is proportional to the surface area. How much would you expect to earn in money? So here we can now look at this as a set of proportions, and we can cross multiply, divide. So 94.2 times 1 is still 94.2, and divide that by 18.84. And when I do that, I get 5 cents. So I'm expecting to get 5 cents for this can. Okay, so that's just a real life application where they may actually have you go through and work with some surface area. Understand that surface area includes your top and bottom, as well as the lateral surface area in the middle. Pay attention if they ask only for lateral surface area, that is just this middle rectangle that is basically kind of like the label of a can. Good luck with this section.